using the shapes tool. So we want triangle tool, and it says at the bottom, a little lower. Oopsies. This thing's out in my way. You go up to draw a right triangle. I hold the shift key down. So hold the shift key down, and you're going to go along the diagonal or the hypotenuse. So shift key, hold it at the top, click and drag to the bottom. Okay. They're telling us, so this isn't to scale. So if you looked, it said that was 41. It says it's 40, and that said 51.5. So we're putting the 40 degrees in there. So go to the equation tool, put in 40 degrees. I'm not going to be too picky. I'm going to put the degree symbol in there, but I'm not going to be super picky when you're doing some quiz or test. Whenever they're giving you a distance, it is understood, unless it's explicit, put it away, horizontal distance. Okay? All phones should be away. All your bugs should be out. So along the bottom, this should be 20 meters. So I'm going to put 20. 20. That lets me. All right. And the last thing we need to label is what we're trying to solve for, the height of the tower. So I got two things left. I got this vertical piece right here. I got that horizontal, or that vertical. Okay. If height was along a diagonal, then I don't know, I could say I'm 8 feet tall. Because if I measure from myself probably to the two chairs where the gentlemen are, I'd be 8 feet tall. Am I 8 feet tall? Okay, so height is vertical. So that means this is H. And then, now that I have everything labeled, next step is I'm going to label opposite, adjacent, and hypotenuse. When you're really comfortable with these, you don't have to put these in. But until you're really comfortable knowing which trig function I'm using, put them in. So here's my angle. So the piece that is next to the 40 degrees is my 20 meters. And since that is touching the 40 degrees, that is my adjacent. Remember, adjacent and opposite only refer to your legs, the two things that make the right angle. And if you want to be real specific, put the right angle in here. You make a little rectangle and hold the shift key down. You can make a little right angle right there. Look at that. Look how pretty that is. Come on down. A little bit more. A little bit more. All right. Good enough. All right.
Oh, no.
So over here, this is opposite. So that is, oopsies, OPP. Now that I know, that I'm using my adjacent side and my opposite side, I look at toa. Tangent is opposite over adjacent. So I set it up. So sine 40. I don't need to see the degree sign on this one. Caps lock key off. Otherwise, when we put this in Desmos, it's not going to work out too good. So 40 equals, oops, not sine. We just said tangent. Tangent 40 equals h over 40. H or x, I don't care. Doesn't make a difference. Because Desmos, we're only really interested in doing the arithmetic on Desmos, not the x itself. If we were graphing stuff, and will we be graphing? Yes, but not anytime in the next 2 weeks. Okay, so we're going to graph probably the first week in May. All right, multiply. So Control A, Control C, show my work. Control V, multiply both sides by 20. Okay. Whatever you one side. Notice, where am I putting the 20? Next to the 40? No, because then that's tangent of 800 degrees. We do not want to do that. Just put it in front. Okay. We take the tangent of 40 times 20 and put that in the Desmos, which I did right here. Look how pretty and organized it is. This is the tower problem. So 20, 10, 40, 16.8. And you're going to answer it in a sentence. Go to the text box. The height of the tower. Height of the tower is 16.8 meters. Just use M, that's okay. Questions? Everything you need to see, okay? If you don't put the OPP and ADG, I'm okay with that, as long as you understand which trig function you're using. If you're not real sure yet, you need to put them in there. Okay. Good. Try the next one. Try the helicopter. Helicopter problem. So we're looking at opposite and hypotenuse. So that is sine. Sine of the angle. So sine x equals 24 over 45. I know I'm on the right track because I know sine is supposed to be less than 1. If I have 45 on top and 24 on bottom, that would be bad. Okay? Let's just see what happens if I try to do that on Desmos. Okay? So if I try to take the inverse sine, right? sin -1 of 45 24ths. Hey, what happened? That means I did something wrong. Okay? Because I can't take sine of a fraction that is greater than 1. So that would be wrong. This would be right, but I can take the inverse sine of 24/45, which I did. Let's see. This was the helicopter. There it is. Inverse sine of 24/5, so 32.2 degrees. Okay.
See, you were right.
So you write a nice little sentence here. The measure of the angle. Oopsies. Eek. So the measure of the angle of elevation. I do not like typing one-handed. Measure of, oh my gosh, the angle of elevation is 32.2. And in this case, you can do one of two things. I want the units. So you can either write out the word degrees, or if you wanted to get fanciful, you could go to your equation editor. You go up here, and the degree symbol is right there. Okay? Questions? Yes, ma'am. I have to take the inverse sine. 32.2. Make sure you're in degrees. Because the default, every time you open up a new file, it's going to be in radians. But here's the good news. When you save and you're doing stuff in degrees, when you open it up next time, you don't have to reset it to radians. Okay? So once you save with degrees, it'll stick with degrees. And that is the helicopter problem. All right. Uh-oh. There's not a picture. So we need to make one. So go to the shapes tool. Go to the triangle tool. Hold the shift key down. Angle of elevation is 7 degrees. If I want to make this to scale, watch this. Look at the bottom. Okay. So I just need to scoot this over a little bit. 70 degrees. Okay. 65 meters long. Whoopsies. So that would be the hypotenuse, because the string does not go on the ground. That would be a very different type of kite. Not a kite at all. 65 meters. How far is the kite above the ground? So that's vertical height. And we are looking for what's 70 degrees. Last thing put. So 70 degrees. Come on, Kimmy. There we go. All right. There's the setup. You do the rest. Find the height. Write a sentence. The kite is blank meters above the ground. You do the rest.
Is it Mikey?
It is not Mikey. Mikey likes it. Never seen that old commercial?
No.
Sine. So sine of 70. So in the old commercial, they were trying some new cereal. It was called Life. Nobody wanted to try it because it was the new cereal. And then they had the little kid. They said, Mike, you'll try it. Hey, Mike, he likes it. And that was like 20 years, a very famous saying. So how do I solve? Divide by 60? No, I have to undo the division and multiply. So this is my kite problem. So 65 times 70. 65 sine 70. I looked at one student's work and I wasn't sure it was wrong, but I knew it was wrong because the number here was bigger than the hypotenuse. Why is that a problem? Because the hypotenuse has to be the biggest. So if you set up and solve and you get this great answer, your setup is probably wrong. Got that, Derek? What has to be longest, Derek? Okay. So in this case, how far is the kite above the ground? The kite is 61.1 meters above the ground, or meters. That is a really long kite string. That's like 6 stories tall.
Ooh, do not have a kite in Afghanistan.
Kite Runner, did you read the book?
I'm reading it right now.
Okay, so the kite is 65 meters.
Very good.
Don't fly kite Derek Cliff. There was a major kite designer, and he would always test his kites. And he had stackable kites. He just stacked one too many. Pulled them off the cliff. Yeah.
That's like, imagine dying by your own kite.
One of the guys who's responsible for basically modern aviation, he would test they were gliders, and he would just jump off a cliff on his gliders, kind of like those crazy people in those flying squirrel scoots.
Like that from Scooby-Doo?
Yeah.
Like, in Scooby-Doo, remember the guy who makes his own wingsuit and he has to fly?
Okay, so 65 was hypotenuse. So remember, nothing can be bigger than that.
I know his name.
Okay, so if that's 65,
your answer is.
Oh, no.
and that was wrong. That's what happens when I talk about more than one thing at a time. Thank you, Birdo. All right, 2 ways to do this. One shortcut.
45 or 5.
Okay, so think about how to do this one.
It's not Old Man Smithers. That's the first movie.
Skater is number 1.
Because I'm using 10, which is opposite side, and x is the hypotenuse. Okay? So sine 45 equals 10 over x. Remember, when you're solving for x in the bottom, take the x and the 45 and switch them. So x is equal to 10 divided by 45. You will know you have the right answer, or you'll know you have the wrong answer if your x is smaller than 10, because x represents the hypotenuse. Remember, hypotenuse has to be bigger. So we're looking for something that is bigger than 10. So if I put 10 divided by sine 45 in, I will get something bigger than 10. What's the shortcut here, Derek?
45.
So how does that help me?
If it's 45, then those two towers are like the same.
Okay.
And then where x should be is like x to the
Square root of 2. Okay. So you can do it either one of those. Okay. So this was missing side length, right?
Yeah.
So you can either do it 10 divided by sine 45 or 10 times square root of 2. You guys are special, so I'm doing it a third way just for you. Okay? Sine. So if I don't want the x to be in the bottom, instead of using sine, I could use cosecant. Okay? So if I use cosecant, and I wouldn't recommend this on the regular, but anytime you have x in the denominator, it tends to mess up some of you. So cosecant, SC, 45 equals x divided by 10. Because if I do it this way, then it's just 10 times cosecant. If I come here, 10 cosecant 45. Hey, look at that. I don't care which way you do it, as long as you come up with 14.1. Questions? Okay. Hey, we're done. So, open up the assignment. Let's start looking at